Hello everyone, this is day 9, question 2 of our Leetcode activity elimination game. So we have a list array of all integers in range 1 to n sorted in strictly increasing order. That is basically we'll have 1, 2, 3, 4, 5, 6, 7, 8, so on till n. Apply the following algorithm on array. Starting from left to right, remove the first number of every other element afterwards until you reach the end. Repeat the previous step again, but this time from left to right. No, sorry, from right to left. Remove the rightmost number and every other element from the remaining number. Repeat the steps again, alternating left to right and right to left until the single number remains. Given the integer n, return the last number that remains in array. So let us understand the question through example. So n is 9. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So first of all we have to remove from left to right starting from the first number. So 1, 3, 5, 7, 9. So one thing you can observe directly is that all the odd numbers are eliminated in the first round. Okay. Then the second round we do the same but from right side. So the first number is 8, skip 6, then 4, skip 2. So 6, 4 and 8 are removed. Now again from left only one element 2 is removed as we skip 6 and the sole remaining number is 6. Therefore the answer is 6 and the output is 6. And also we can see that if n is equal to 1, always n will be the output as only the sole number remaining will be n. N will be 1. So what approach can we use? So the pseudo code for this is if n is equal to 1, return 1. That is our base case. As if 1 remains, always number remaining will be 1. Otherwise, m is equal to n by 2, return 2 into m plus 1 minus solve m, and solve is the r function itself. So here we are what we say using recursion, the function is calling itself. But from where does this formula come? So let us derive that formula. So first of all we'll define two functions. First function is L of n, which is winner of 1 to n when the next elimination round starts from right to left. Remember next elimination. Now Rn, it's winner of 1 to n when the next elimination, again I'm emphasizing on next elimination, starts from right to left. So and what are the winners? Winners are nothing but the numbers which remain, which do not get removed from the array. So our goal is to find ln, as ln is the exactly the original problem, that it is the f of n. Okay, so let us dry run for after the first elimination. So 1, 3, 5, all the odd remaining will be gone. So 2, 4, 6, 8 remain. Now you can notice that these are, if this array was one indexed, these are exactly twice of their indices 1, 2, 3, 4, and we have just multiplied by 2. So generally 2, 4, 6, and so on to 2m will be the survivor of the first operation. And m is what? M is n by 2. Then the next eliminate direction is right to left. So now instead of 2, 4, 6, 8, why don't we think about 1, 2, 3, 4? as the number value doesn't matter. The only position and the direction of elimination matters. Yes. So elimination pattern depends only on positions. Therefore, winner of 2, 4, 6 to 2m will be equal to 2 into winner of 1, 2, 3, so on till m. Yes. And since the next direction is right to left, as we applied first left to right, the next direction is right to left. And when the next direction is right to left, what did we call that function? R. And when next direction was left to right, we called that L. So now we performed L, and the next winner, so the winner can be written as 2 into 1, 2, 3, 4, and so on to them. We can write the ln is equal to 2 r m, where m is n by 2. Now, how we will find the relation between ln and rn? Consider, if we perform operation left to right, what all will remain is, let us mirror it, then run right to left on the original sequence is equivalent to reverse sequence, run left to right, then reverse answer. That is, if I'm thinking of right to left operation, that is same as mirroring the array and performing left to right of operation. Simple. So now think, when I'm going left to right and right to left, the survivors will be mid the mirror of each other, as we are nothing but we are performing a simple operation, is that starting from the first position, delete every other position. So if we start from this end and do it for every other, or start from this end, do it for every other, don't you think that the survivors or the elements which will be removed will be mirror of each other? Such as, if one is going to be removed here, from left to right, from right to left, n will be removed, so on. 2, if 2 is going to be removed here, n minus 1 will be removed. So in generally, if x is going to be removed, n plus 1 minus x will be removed, and this n minus x plus 1 is used in, I guess, palindrome question 2. This uh, trick is used. It's not a trick, it's a simple mathematical equation which gives, if a number is x the number, nth number from left side, then from the right side it will be n plus 1 minus x. So therefore, what we can say, for Rn, n plus 1 minus ln, as x here is from the left side, from the right side it will be Rn. If from the left side x is surviving, then from the right side n plus 1 minus x will survive. So if we are starting from the right side, we called it Rn, and if we are starting from the left side, we called it ln. So Rn will be equal to n plus 1 minus ln. So now we also defined earlier ln is equal to 2 into Rm. So now substitute, instead of ln, this will be Rm is equal to m plus 1 minus lm. From here we have just substituted n to m. Now Rm. What is Rm? Rm is ln by 2. From this we can say Rm is equal to ln by 2. So here ln by 2 and 2 is shifted here. So ln will be equal to 2 into m plus 1 minus lm. Since the original answer was ln, just replace ln by fn. So now fn is equal to 2 into m plus 1 minus fn. And what was m? M was nothing but n by 2. So fn will be 2 into n by 2 plus 1 minus f into n by 2. And this is our recurrence relation. This is our recurrence relation. We will use this to apply our recursive approach. Now base case was only one number exists, then 1. Then 1 is the winner, obviously. So f of 1 is 1. So let us try a recursion tree for n equals to 9. So for n equals to 9, here we are calling n by 2. So 9 by 2 is 4.5. We are taking the floor. So 4 by 2 is 1, and 2 by 2 is 1. So as we hit 1 here, this will return 1. Now when this is returned 1, for f of 2 we'll calculate into 2 into n by 2. So n by 2, 2 by 2 plus 1 minus f of n by 2. So f of 2 by 2 was 1, f of 1 was 1. So 1 plus 1 minus 1, this is 2. So now this will return 2. Again 4. So 2 into n by 2. So 4 by 2 is 2 plus 1 minus f of n by 2. So what was f of n by 2? So f of 2 was 2. So that we have returned here 2. So again 2 minus 2 plus 1 into 2. This is 2. And for 9, 2 into n by 4. The n by 2. That is 9 by 2 is 4 plus 1 minus f of n by 2. So f of 4 is 2. So this here it is 2. And this comes out to be 6. And this is the pseudocode. Let us first verify 6. So 9 output is 6. So our logic is correct. So function solve n. If n equals to 1, return 1. This is our base case. And if we don't hit our base case, we return 2 into n by 2 plus 1 minus solve n by 2. Let us see the time complexity. Now, again, we are reducing our n by 2 for each step. So, if it was n, so we ideally go till the point where only one elements remain. So n by 2 raised to k should be 1 if k is equal to number of operations. So n is equal to 2k, taking log both sides, log n will be equal to k, and this is our time complexity log n. So I will tell you a mental model or like a simple trick. Whenever you see that the search space or the input size is getting reduced or divided by a certain factor, let us call that factor a, then you can always say that, and it is being reduced until and unless the just one element remains and you take k operations, you can always say that n a raised to k should be equal to 1. That gives n is equal to a raised to k, and you can take log a both sides, so that will give log a n is equal to k, and this will always be our time complexity. So whenever you see dividing the input size by a certain factor on the each step, and we stop when we only have one element, the time complexity is generally log n, and if you want to be precise, you can say log n base to the number or the factor we are reducing the input space by. And this is how we solved the question elimination game through recursive approach. Thank you.